Okay, we've got a little bit of a conundrum in this course. The problem is, some people that are registered for this course are in the distance course for Math 161, which started last Tuesday because you didn't have to be here to do that stuff. So they're moving way ahead of where we are, where the other classes are. So out of sync. I think I said something to that effect last time, but I'm giving pretty intense assignments in this course this week and next week to get us, well, to accommodate those students. Now, I'm still not sure what to do to accommodate students who are moving at a slower pace. It might be that if you're in my class, for example, and get the work done a little bit later, I can accept it for full credit. There is a half credit page, and you find that half credit page. If you register, it's another open math. It's so-called course. It's the same course, but it's a different page where you can submit the homework for half credit if it's late, and no time limit on that. And the due dates and all that homework are sometime next year. Okay, sometime in 2025, or even 2026. So, yeah, the point is, that's there without any restriction on when it's available, and you can always do the assignments there. What I'll probably say is, and I haven't totally sorted this out. I've been thinking about it, looking at what people get done, you know, if they get my homework done and so forth. And just see where people are in this course. I haven't totally sorted out the way I'm going to do that, but I'll get you an email and we'll kind of get that on track by next time. Okay. Anyhow, I am going to go over things that are important for the first three sections of the text, which in my class we're not going to get to for a couple of weeks. Okay. In some other classes, we're getting there. In the distance class, students have the first three sections of the text due on Thursday. So I'm going to spend today going over stuff that's going to be important in the first three sections of the test. Now, if you're in my class, you'll see, you might not see right away how that fits in, but you will soon. You'll see some of it later today in my class. So I really can't say too much about it at this point, because if I say a whole lot more about it, you won't have a point of reference to understand what I'm talking about. So what I'm going to do here is we're going to talk first about function notation. Okay. And I'm going to write down an expression here, f of x equals the square root of x. Okay. Now, I want you to write down just exactly what I've written here, but write down just what I've written down there, but instead of x, write a. Okay, now again, if you're not here today and you're looking at this video, or if you're a distant student looking at this video, you should have stopped and done that. You still have time, but I'm going to do it now. You don't want to see this until you've done it yourself. You might get it right and you might not. Some of the class got it right, some of the class made the mistake of maybe thinking about what they were doing. Okay, if you think too hard, you could write this wrong. We're just replacing x with x. We have f of x equals x. So if we write this expression, we put an a here and an a here, what's it gonna look like? It's gonna look like f of a equals square root of a. Okay. Now write with x replaced by x plus h. Okay. Well, if we replace x here by x plus h, we write our f and we write our parentheses, but then we got to put x plus h where x was. Okay. And then what do we have? We have the square root. This is square root of x, but we replace x by x plus h. Okay. Now, this is not this, because x is inside parentheses. When you replace it by x plus h, it has to stay inside the parentheses. And not this, because x is in this, under the square root sign, so that x plus h has to be under the square root sign. Okay? So it's not this. And I've seen a lot of this, especially when we start doing things with these notations. So no. Okay? But be careful. Okay? Now I say write the expression f of q plus 6. When I write f of q plus 6, there's a q plus 6 in here, I've replaced x by q plus 6, haven't I? Well, that means I've got to replace this x by q plus 6. So when I say write this expression, well, write this and then fill in the other side. Okay. Double check. Yeah. Okay. So it's the same thing, except this time if I say f q with a q plus 6 in parentheses, that means that x is now q plus 6. So x has to be q plus 6. This x has to be replaced by q plus 6. So we don't write f of x here, we write f of q plus 6. And I hope if you're watching this, that you're doing this as intended. If you sit back and watch what I do and then say, okay, I understand it, you might. But if you're not doing it yourself, you're not engaged, and I don't think you're going to learn it as well. Okay. Okay, so let's try this. About F4. You write out F4. What's that equal? Okay, so again, we go back to the definition of f of x. X has been replaced by 4. So we've got to replace this x by 4, and we have then the square root of 4. Okay, and you might know that the square root of 4 is 2. Didn't ask you to evaluate that, but everybody should understand that the square root of 4 is 2. Again, if you're watching, hopefully you wrote this down before I showed you. And maybe you thought, okay, the square root of 4 is 2. Maybe you added that. That's not really necessary at this point, but I'll just mention it. Okay. 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 That's right. F of x plus 0.01 minus f of x. Okay, now this is a little bit of a question. Some people have a little bit of trouble figuring out how to write this. But f of x plus 0.1, I'm going to break it down. I'm going to break it down into 2 simple things, and then we'll put them together. Now, if I ask you to write out f of x plus 0.01, I'm pretty sure you would have written the square root of x plus 0.01. Okay? So that's there. Then we got a minus sign, and then we got f of x. Okay? We can say that f of x then equals the square root of x. And that's just the definition. Okay? F of x has to be this. So f of x plus 0.01 minus f of x equals what? It equals the square root of x plus 0.01 minus the square root of x. Now, there are things you can do with this algebraically, but we're not going to deal with that algebra right now. That's actually fairly we do some fairly advanced algebra with this a little bit later, but we're not going to deal with the algebra. We're just writing down the expressions. Okay? Okay. Well, that's what we mean by function notation. Okay? Now, if we have a graph, and I think most people have seen the squaring graph, okay? And in my class, we've just seen the shape of the squaring graph. And when we get to class, I'm going to ask you to construct that shape. But, you know, if we construct that shape in a rectangle, it's going to look something like this. Okay. Now, if we have a y-axis and an x-axis, then the line through each line, each vertical line through the edge is associated with an x value. Now, we don't know, we don't have a scale on this. We haven't marked off the scale, but I'm going to say that this left line is at x equals 3. And this line is at x equals 7. That isn't quite drawn to scale, but we're going to declare that anyway. Okay. And then we have lines here. And this line is y equals 2 and y equals 6. Okay, well, explanation of that, you might not be all that familiar with the coordinate plane, but It just means that every point on this line is directly above the point on the x-axis where x equals 3. Okay, the coordinates of all these points, the x coordinates of all these points are 3. The y coordinates of all the x coordinates of all these points are 7. The y coordinates of every point on this line, the y coordinate is going to be 2. For every point on this line, the y coordinate is going to be 6. Talk more about that in my class, but hopefully everybody has some fairly decent understanding of this. Okay, so my question is, what's the value of x? What's the value of y? At this point right here. Now, can you kind of quickly sketch that picture and see if you can answer the question of what the x and y coordinates of that point are? Okay, now hopefully you got the picture drawn and you included all the details. Now, people have been leaving off a little bit of details, so we want to get all the details. Like I've got an arrow on the x-axis and I've got it labeled x. I've got an arrow on the y-axis and I've got it labeled y. So we can distinguish the x and y axes from the rectangle that we constructed this parabola in, okay? So we want to have that. Now we've got dotted lines. Okay, and the dotted lines extend over here and they extend out beyond the rectangle to indicate that, very clearly that this dotted line goes through the bottom edge of the rectangle. And this dotted line goes through the top edge. Okay, and this dotted line comes out the top here. And this dotted line comes out the top and it extends down below the x-axis so we can label everything. Now, the question is, for this point here, and let's, I kind of missed it, but this point indicates the upper left-hand corner of our rectangle, okay? So I'm kind of a little bit off the way I drew it. It's a little bit careless. But if it's the upper left-hand corner of the rectangle, what's the x coordinate and what's the y coordinate? Well, we write x, y equals, and we put parentheses here for the comma, and then we put the number for x and the number for y. What's the number for x and what's the number for y at that point? Okay, well, this point is on the line, x equals 3, isn't it? So what do you think x is? Pull up your fingers. 3, right? It's obvious. Okay, don't worry about too much. If you think x is 3, slop it down. If you're not sure, slop down something so I can see what you're thinking. Okay. And what's y? Well, tell you a line where y equals 6, so it's the point 36. Okay. So now we're going to now, this isn't the graph we used before. This is the f of x we used before. It's no longer the square root of x. It's something else. If y equals f of 3, then what is y? We're going to have to keep moving. First of all, we say that this is the graph. This needs a little more explanation. It's kind of an incomplete question that I gave you. This we did pretty well on, so you're still thinking. If this is the curve, is y equals f of x. Okay? So that's what this curve is. This curve defines what f is. So if x is 3, the point on the curve has y coordinate 6. So that means it's the y coordinate point on the curve for x equals 3. And the point on the curve where x equals 3 is a 0.36. We say that y equals f of 3, which is 6. Now, the curve has an equation. You don't know how to get this at this point, but you will within a week or so. Y equals f of x equals x minus 5 squared plus 2. It's a squaring function, but it's not the canonical squaring function, not the basic squaring function, the basic toolkit squaring function. It's a squaring function because it has the shape of a squaring function, assuming we've constructed it that way. So the question is, now y equals f of 3, and it should be 6. But let's use the formula to see what happens. Now, what would your expression be for f of 3? Just the way we did it before. You're just going to replace x by 3, and you're going to write this expression out. Okay, so we write y equals f of 3 equals what? Well, f of x is this. So we've replaced x by 3. That means we replace all the x's by 3. So if I just write this expression out, but 3 instead of x, we get 3 minus 5 squared plus 2. Now, that's simple arithmetic. You can evaluate that. 3 minus 5 is negative 2. Now, I could say negative 2 squared is 4, but let's be sure we understand what we mean by negative 2 squared. That means we multiply negative 2 by itself. That's how you square a number. And negative 2 times 2 is 4. And 4 plus 2 is 6. And like magic, I didn't lie to you. Okay, I said this equation represents this curve. Well, at least for that point in the upper left, it's so. And it'll be so for every point on the curve if the curve is drawn with complete accuracy. Of course, we can't draw it with complete accuracy, but we get the idea. For example, now, well, I don't want to go any further with this. I want to make sure that we have a basic beginning understanding of function notation. So you might have a much better understanding of function notation depending on your background, okay? Theoretically, in this, for calculus course, you should come in understanding a lot of this, okay? But there are nuances to it. There are little details that you probably aren't aware of, so try to pick up on them, okay? Okay, well, that's my first attempt to explain function notation. And now we're going to move on. I still want to talk about this function of f of x equals x. So we've got f of x equals the square root of x. I'm going to stick with that function for a minute. Now, the square root of a number is the number you multiply by itself to get that number. So for example, the square root of 25 is 5 because 5 times 5 is 25. The square root of 4 is 2 because 2 times 2 is 4. Square root of 100 is, can you show me with your fingers, what's the square root of 100? What do you multiply by itself to get 100? Yeah. Well, okay, 10. 10 times 10 is 100. We have to understand those numbers, or at least believe them. Of course, you can put in square root of 100 into your calculator and it'll tell you 10. And then you can multiply 10 times 10 and see that it gives you 100, right? So you understand what the square root is, and hopefully you understand what square roots are. But if not, you can develop the understanding by understanding these functions, okay? Now, f of x equals square root of x. Four is the square root of 4, as we understand by replacing all these x's by 4. And the square root of 4 is 2 because 2 times 2 is 4. Okay. F of 25 is square root of 25, which is 5. And 5 times 5 equals 25. F of 100 is the square root of 100, that's 10. That's 10 times 10 equals 5. What's f of negative 4? Okay, well, you can try different things. Can't be 2 since 2 times 2 is 4, and that's not negative 4, right? Negative 2 times negative 2 is positive 4. Okay, so it can't be negative 2 because it doesn't give you a negative number. If you multiply a negative by a negative, you're going to get a positive, right? So you can conclude that f of negative 4 would be the square root of negative 4. And I could be a little more explicit. f of 4 is the square root of -4. So what's the square root of -4? Well, there's no number you can multiply by itself to get a negative number. I'll make this statement. It's a very important statement. You got to understand it. In terms of this example, you can see that if we try to square, if we try to multiply a positive number by itself, we get a positive number. If we try to multiply a negative number by itself, we still get a positive number. So we're stuck. We can't find a square root of -4. So we say that f of x equals square root of x is defined only if x isn't negative. I.e., if x is greater than or equal to 0. Okay. Now I want to go to set notation here. You're going to see that in your text. I'm kind of making a jump, but if you've done the introduction to MyOpenMath, you've been asked to write intervals. So you should understand that this stands for the interval on the x-axis of all numbers from 0 to infinity. Okay, so we could draw that interval like so. Here's 0. And this arrow indicates the ray that's the domain of this function, but we also have to include 0. If we draw it without a dot on 0, I'm not sure whether 0 is supposed to be included or not, but it is. And the square root of 0 is 0 because 0 times 0 equals 0. Okay, so this is a domain. F of x equals the square root of x. Okay. And I guess we're about board space, we'll just move the board over a little further. We'll get there eventually. Okay, so we're gonna go further. Yeah, I think we got it. All right. Now. How about f of x equals the square root of x minus 7? What's the domain of this? The question then is, well, Are there any X numbers that you could put in here? Well, this wouldn't give you a result. So, question. Can you give me a number for X where you couldn't do the square root? Okay, well, I'm not sure why I stopped recording, but I'll briefly over what I did. Got f of X equals the square root of X. F of 4 is the square root of 4, which is 2, since 2 times 2 is 4. F of 25 is the square root of 25 minus 5. Square root of 25 is 5 because 5 times 5 is 25. F of 100 is the square root of 100, which is 10, since 10 times 10 is 100. So question now is, what is f of negative 4? Well, f of negative 4 is going to be the square root of negative 4. We just replace our x's by negative 4. What are our possibilities? You think maybe 2, because the square root of 4 is 2, but it can't be 2, since 2 times 2 is 4, and it's not negative 4. Okay. And it can't be negative 2, since it's negative 2 times negative 2 is positive 4, not negative 4. You multiply two negatives, you get a positive. And at this point, you think, well, okay, if the number here is negative, you're never going to find two numbers you can multiply together. Because if you multiply two negatives, you're going to get a positive. If you multiply two positives, you're going to get a positive. You'll never get a negative number by multiplying any number by itself. So we say that the square root of negative 4 isn't a real number, since any number multiplied by itself is positive. Just another way of saying what I just said. Okay, so f of x equals the square root of x is defined only if x isn't negative. That means x has to be greater than or equal to 0. Okay, so we say the domain of f of x equals square root of x is the interval from 0 to infinity. We include 0. And if you've done the open math assignment that was assigned, the introduction to my open math, you understand the interval notation, okay? Because that was in there. If you don't, you better do it. Okay, so 0 to infinity. All right, well, now how about f of x is the square root of x minus 7? Okay, we went through several examples. F of 10, well, you replace x's by 10, you get square root of 10 minus 7, which is the square root of 3. You can't write out that number. You can write out an approximation. Your calculator will give you a lot of decimal places. Okay. We know that the square root of, well, 1.7 times 1.7 is 2.89, which is less than 3. 1.8 times 1.8 is 3.24, which is a little more than 3. So somewhere between 1.7 and 1.8, you got the square root of 3, but you'll never find it. Okay. Now, approximately 1.732. Something in the days before calculators. Every college transfer level student in high school knew that by the time they were 13. And can't forget it. I couldn't forget it if I tried. Hit myself in the head real hard if I maybe forget it, but I'm not going to do that. Okay, and anyhow, f of 10 is a number, which is square root of 3. F of 9 is square root of 9 minus 7, which is 2, which is between 1.4 and 1.5, because 1.4 squared is 1.96. 1.5 squared is 2.25. And it's actually approximately equal to 1.414. It's a pretty accurate approximation. Okay. F of 6 is the square root of 6 minus 7, which is the square root of negative 1. And you can't do a square root of a negative number. It's not a real number. And if you're dealing in the real numbers as we are right now, it does not exist. And that's the definition does not exist. Okay, the abbreviation that you use, and I think you see that in the introduction to my open math. Okay, now what about f of 8? The square root of 8 minus 7, square root of 1, that's fine. F of 7, well, it's the square root of 0, that's fine. But if we go to 6, here's f of 6, we just saw that it doesn't exist. So we've got 7, 9, and 10 and 8's in there. that do exist. We got 6 and the f of x doesn't exist for x equals 6. And it turns out that, well, the smallest number we can use is 7 because that's what gives us 0. If we put a number smaller than 7 in here, we're going to get a negative. 6.9 minus 7 is negative 0.1. So we're stuck if we go less than 7. So here's our domain. We put a big dot on the 7 and an arrow to the right. There's our domain. In interval notation, it would be, instead of 0 infinity, it would be 7 infinity. 7 would be included, so you use the closed bracket. Okay. Now, f of x equals square root of x minus 7 is defined as long as x minus 7 is greater than or equal to 0. Okay, that's what we've just been explaining to make sure we understand this. So that means as long as the thing under the square root thing isn't negative. Okay? Because whatever's under the square root of sign can't be negative because you can't multiply two numbers and get a negative. You can't square a number and get a negative. You can't multiply a number by itself and get a negative. Okay? So we could write the set of valid x values by just writing the inequality that x minus 7 is greater than or equal to 0, meaning it's not negative. Okay, if you're greater than or equal to 0, you're not negative. So we can write that as an inequality, and then we just use the rules of algebra. And we went over the appropriate rules of algebra on the first day, and we have to assume that you know these. But x minus 7 plus 7, add 7 to both sides, add 7 to this side, we get x greater than or equal to 7, and that's exactly what our domain was. Okay? Now, I had to say that kind of fast because we've already said it in class and I wasn't recording. I might have recorded some of it if I didn't record all of it. Okay, there you got this function, g of x equals the square root of 6 minus 4x. What can you say about the domain of this function without giving me numbers and stuff? What can you say about the domain? Well, okay, for this one, your domain is restricted because whatever's under the radical sign can't be negative. We have to understand why that's true, but now we're just going to take the fact that it is true. Now, you don't want to just memorize the fact that it's so. You want to understand why it's so. Otherwise, there are things you're not going to understand. Okay? But it's simply because you can't multiply a number by itself and get a negative. So, can't be negative, so it's got to be at least 0 or greater. Well, we can solve this inequality. Okay. Use a little algebra that most people are going to screw up at this point in the course. I'll point out where that happens. I'm going to subtract 6 from both sides. In the right-hand side, 0 minus 6 is just negative 6. The left-hand side is negative 4x. Then I'll do the obvious thing. I'm going to divide by negative 4. And that's going to give me x. So I divided this side by negative 4, and I've divided this side by negative 4, but I made a mistake. A lot of times when I make a mistake, it's just because I'm being careless or stupid or something. But I intentionally made a mistake here to see if you can spot it. Can anybody see what's wrong with this? Anybody want to say? If you do, just kind of raise your hand up, pause. Okay. Well, the thing that's wrong here is that when I multiply or divide both sides of an inequality by a negative number, that flips the inequality. And that's the one thing that's different about an inequality than an equation. If you multiply or divide both sides by a negative number, you got to flip it. Okay, I'm not going to write that down. I'm just going to say, okay, well, this tells me then that x is less than or equal to 6/4, which of course is 3/2. And now we say that the domain of g of x is the interval from negative infinity to negative 3/2, which we can make sense of by putting negative 3/2 here, putting a circle around the negative 3/2 because it is less than or equal, and drawing an arrow toward negative infinity. So there are other notations. These are the most common. This is the most common notation Open Math uses. And if you understand this, that's enough. Then if other notations, I get all choked up when I talk about domains. Okay, some dust or something. If you understand this and this, then you'll pretty easily be able to understand other notations for domains. Okay. So there we have it. All right, now there are other restrictions on the domain. We're kind of almost out of time. Yeah, 1 minute, almost exactly. This is probably change. But let's take h of x equals 4 over x minus 2. Is there any number that you just can't use for x and get an answer? Now, again, if you're watching this, when I ask a question, stop and think about it. Don't just wait for me to answer, because then you don't learn anything. Well, you don't learn as much. You might. Depends on how complex the answer is and how much you knew when you came in. But you know, if you're used to the idea of domain, it becomes pretty natural. Please don't walk in front of the camera.
Okay.
Okay. Division by 0 isn't defined, so x minus 2 equals 0 is forbidden. Now you're going to get struck by lightning if you do it, but you're going to make an error. Okay. And we solve that easily. We get x equals 2. Is forbidden, and we're out of time, but this is the other usual case when you have a restriction on the domain of a function. The denominator can't be 0, and you can't do the square root of a negative. Now, there are other restrictions, but that's 90% of the ones you're going to encounter. So you want to be sure you understand those two things. There's also the idea of range, and of course, we don't have time to talk about that today. But right there, you have a foundation for the first couple sections of the text. Okay. When we get to it, if you're in my class, and when it's due day after tomorrow, if you're in the distance class, that, as we said, is ahead of this class because of the snow days. Distance class didn't observe the snow days because they don't need to, because they don't have to be here. Okay. Just because the campus is closed doesn't mean you shut down the distance courses. All right. Well, very good. Y'all did well today. Review this if you need to. and make sure you understand every detail of it, because it'll do you a lot of good a little bit later if you're in my class when you see it. Okay? And if you're not in my class, of course, everybody here right now is in my class, I think, but if you're not in my class, do it because you're going to need it. Unless it happens that, you know, if you're in the distance class, you got a quiz Monday. You got to know these 3 sections. If this helps you, great. If it doesn't help you, well, I hope you do well in the quiz. And if you don't, we'll talk about it then. Okay. And if you're in another section, there are people in still in another section. We'll see how that goes. I'm not sure where that section is. I've got to talk to that instructor a little bit later today. Okay, very good.